This video is 2.4 angles of a triangle. Now for this video, there will be an activity towards the beginning of the video that you will need a piece of paper that you can cut up and some scissors. So go ahead, pause the video, gather those materials, and then come back. Okay, so classifying triangles. We have a few different ways that we can classify triangles. We can classify them by sides and by angles, okay? So a scalene triangle has no sides that are the same. An isosceles angle has at least 2 congruent sides. Equilateral has 3 congruent sides. That means that equilateral, because isosceles has at least 2, equilateral is actually a subset of isosceles, okay? When we do it by angle, acute triangles will have 3 acute angles. An equiangular triangle means that, just like it says, it has 3 congruent angles. Now a right triangle has 1 right angle and 2 acute angles. And then obtuse has 1 obtuse angle and 2 acute angles. On the next slide, we have all of the definitions for you to be able to write down in your notes. Here are some definitions for you if you would like to write them down. So they have them here by sides and by angles. So go ahead and pause the video and take as long as you need to write those down. Now we could say that we have an obtuse isosceles triangle. So that would mean that the isosceles triangle has at least 2 congruent sides with 1 obtuse angle. So make sure that these definitions are all written in. Okay, here's the activity that we're going to be doing today, okay? So when I look at this, first I want you to cut out a scalene triangle. It doesn't have to be perfect. Just cut out any triangle that you want. So it could look something like this, or it could look like this. Draw some kind of triangle and then cut it out. Try to make the edges as straight as possible. Once you have it cut off, rip or tear off the 3 corners. Do not cut them. I want these to be very rough edges here so you know which ones were part of the straight triangle. So these edges here, when you cut it off, will look like straight, will look straight, and you'll know that this piece was not part of the triangle, okay? Take a moment, pause the video, and put all of the straight edges together and see what you end up with. Okay, so now that you have put all of the straight edges together, you should see a straight line. You should see that the 3 triangles add up together, the 3 corners add up to make a straight line. They should fit together absolutely perfectly with the torn edges along the outside. So we know that a straight line has 180 degrees, which means that the sum of our 3 angles has to equal 180 degrees. How cool is that? Okay, so here's some useful information that I thought might be helpful for you. So equiangular, all right, we talked about that equiangular means, or equiangular, that all 3 of the angles are the same angle measure. We just found out that a triangle has 180 degrees. We know that a triangle has 3 angles, so if I take 180 and divide it by 3, that's going to tell me 60. So that means that all angles in an equiangular triangle are 60 degrees. I'm just going to do EQUI angle sign are 60 degrees. So this one's 60, this one's 60, this one's 60, okay? In a right triangle, okay, we know that one of our angles is a right angle, all right? The non-right angles are what? Take a moment, think about your vocabulary. They are acute, but we know that a right triangle has 180 degrees. We subtract 90 and we're left with 90. So that means the 2 angles that I have left are complementary. The non-right angles are complementary. Remember, that means that we add up to 90 degrees, okay? All right, now let's look at the third angle theorem. The third angle theorem looks at two different triangles. So if I know that angle A here is congruent to this guy right here, we'll go ahead and call it A. And this guy here, B, we'll say is congruent to this guy here. We'll go ahead and call him B. All right, we want to figure out, what do we know about this last one? I don't know anything about this triangle, this angle here in this triangle. But if we think back, okay, we learned that A plus B plus C, remember the sum of the three angles in the triangle, equal 180 degrees. Over here, we know that A plus B plus whatever that third one is also equals 180 degrees. Well, now we have 180, 180. They equal each other, so let's do substitution. So A plus B plus C equals A plus B plus question mark. Well, I see that this A and B is going to go away, right? Because when we subtract them out, so I'm left with C equals question mark. So that tells me that if two angles of one triangle are congruent to two angles of another triangle, then this is where we get the name of our theorem. Then the third angle of each triangle is congruent. All right, this theorem is frequently forgotten, so you guys are going to be the year that always remembers about the exterior angle theorem. Okay, so first we want to talk about interior angles, and we want to talk about exterior angles. So I have here a triangle with one side that's extended. All right, so this here is the triangle, and all three of these are interior, right? They're inside the triangle. When I extend this line here, this angle right here that's formed is called the exterior angle. Okay, so this is my exterior angle out here. All right, these here, as we know, are a linear pair. All right, because they add up and make up a straight line. So that means these other two interior angles are called remote interior angles. And that's because we call them remote because they're far away from that exterior angle. This angle right here touches the exterior angle, so he's not considered remote. Think about the airport when we talk about remote parking. You're really far away from that airport, okay? So now let's look and do some math here. Alrighty, so if we look at this triangle down at the bottom, okay, we see that we have A, B, C, and D. Now I know that C plus D equals 180, and A plus B plus C equals 180. And we know that because C and D make up a linear pair, and A, B, and C make up a triangle. Okay. So, again, we have 180 and 180, so I have A plus B plus C equals C plus D. I see that the C's are going to go away, and I'm just left with A plus B equals D. So this tells me that two remote interior angles have to add up to the measure of the exterior angle. All right, so that's saying that A plus B are the two remote angles, right? And if we add them up, we get the measure of the exterior angle. All right, so last slide, some more useful information for you, okay? A bisector is something that cuts something in half, right? So it can cut an angle into two congruent pieces. It can also cut a segment into two congruent pieces, okay? Now, when we talk about a perpendicular bisector in a triangle, it does exactly that, okay? It's gonna start at one of the vertices, and we're gonna drop it down, and it's going to make a right angle, right? It's perpendicular to the base, and it's also gonna cut this into two congruent pieces, okay? Now, if we think about this in terms of all three vertices, all right, I can have a perpendicular bisector from each vertice to the opposite side, okay? And this spot right here where they meet is called the circumcenter. So where three perpendicular bisectors meet is called the circumcenter. All right? Now, the circumcenter has a very special property. It's equidistant from the vertices of the triangle. So that means that this piece here is congruent to this piece here and this piece here. They're all congruent.